Hi, this lesson is for Algebra 2 honor students. This is Chapter 7, Factor Theorem and Rational Root Theorem. So let's get started. The first thing we're going to do is a little bit of a review, which is just a long division problem. So we're going to start off with that and check our answers with synthetic division. So starting off with this, I'm going to take the dividend and I'm going to rewrite it here, but be very careful because you always have to make sure that you check for zeros. So you've got 2x to the fourth, and you have no x cubed value, so that's going to be a placeholder 0x cubed. I have an x squared term, so plus x squared, and then minus 10x, and then plus 1. Because what you're really looking for is this 4, 3, 2, 1, and then 0, which you know is not there, but it's still it's there. And then our divisor, which is the x plus 2, goes here. So x times what is 2x to the fourth, so that's going to be 2x to the third power. We're going to get that value up on the top, and then we're going to multiply through. So we get 2x to the fourth power, 2x cubed times 2, which is plus 4x cubed. As soon as you get these values here, you're going to subtract the quantity, and the first term should automatically, every single time, cancel no matter what. 0 minus 4, you have to distribute that negative sign. So not only does it go to the first term, it goes to the second. So 0 minus 4, which is negative 4x cubed, then we start all over. X times what is negative 4x cubed, so that's going to be negative 4x squared. So negative 4x squared times x is going to give me negative 4x cubed, and then negative 4x squared times 2 is going to give me negative 8x squared. And don't forget, I forgot to put this down, but bring down the x squared. So every time you subtract and you have a value, bring down the next term, of course. We're going to subtract the next quantity, and so this is going to cancel. X squared minus negative makes plus, which makes that 9x squared. Bring down the next value, which is negative 10x. And so I'm going to drop this down a little bit here. What we end up getting is we brought that down. X times what is 9x squared? So that's going to be plus 9x. You get that value on the top, and you have to distribute it. So 9x times x gives me 9x squared. 9x times 2 gives me positive 18x. I'm going to subtract the quantity. Again, the first term is going to cancel. I have negative 10 minus 18, which gives me negative 10 minus, it gives me negative 28x. Bring down the last term, which is plus 1. And then you have x times what is negative 28x, so that's going to be negative 28. And I'm going to distribute negative 28 times x gives me negative 28x. Negative 28 times 2 gives me negative 56. And then I'm going to subtract the quantities. And then you're going to cancel that first term. 1 minus negative 56 gives me 57, which means that 57 is my remainder. So I'm either going to write it like this with a plus 57 over my divisor, which is x plus 2, or I would write it in polynomial form, which is, this is my f of x. So I'd say, well, that value is going to equal to my divisor, which is x plus 2, and then times my answer, which is my quotient, 2x cubed minus 4x squared. I'm going to move, I try to move this here over just a little bit. Minus 4x squared plus 9x minus 28, and then you have this, what are we at? Minus 28 plus 57 at the end. And so that would be in polynomial form. This would be just the answer. You just box this whole thing up like this. Okay, and that's just the answer. Now, if I wanted to check this in synthetic division, because, I mean, did I do the right answer? Do I want to multiply this times this and then add that? I think it'd be a lot quicker to check my answer by synthetic division. So that's what I'm going to do. Synthetic division, again, doesn't use the variable. So you take your dividend, which is this middle, this whatever's inside that box. We're going to take that value, which is 2, 0. You need that placeholder right there. 1, 2, 0, 1, negative 10, and then 1. And then what goes in this box is your divisor set equal to 0. So if I take x plus 2 and I set it equal to 0, I'm going to get negative 2. Now remember, with synthetic division, you're adding down and multiplying across. And you always start with this 2. You're adding down, there's no value there, so it's just 2. Multiplying across, I get negative 4. Adding down, I get negative 4. Multiplying across, I get 8. Adding down, I get 9. 9 times negative 2 is negative 18. I get negative 28. Multiplying across, I get positive 56. Adding down, I get 57. And the way you would write the answer in this way is this first term. If you have a 2x to the 4th power, like we did in here, and you're dividing by that x, it's like this. 2x to the 4th divided by x. One of my x is going to cancel. I end up getting x to the 3rd power. So this 2 here is going to be 2x to the 3rd power. So that's x to the 3rd. That's going to be x squared. That's going to be x. That's no x. So it'd be 2x cubed minus 4x squared plus, because that's a positive 9, you take the sign, plus 9x minus 28, and whatever's left, 57, goes over the divisor, which is x plus 2. Cool. All right, so our learning targets today is to find linear factors. We're going to be using the factor theorem and the rational root theorem. We're going to review remainder theorem, long division, and also synthetic division like we just did. So the rational root theorem is this. It says, if you have an equation, and this is our equation right here, okay? If you have an equation, how do I know which values to start dividing if you don't already give me? So like, what value should I plug in into my synthetic division in here? What value should I plug in order to figure out what terms I'm going to start dividing by? So it's a combination of the constant and the coefficient. So meaning the constant is going to be that 6. So see this 6 right here? This is my constant. So it's a combination of factors of that over factors of my x cubed coefficient. All right, that's what it is. And so my factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. The factors of the coefficient, the lead, it's only the lead coefficient, right? The one in the front, are just plus or minus 1. And so all of the possible values that I would be plugging in to see if any of these are roots would be a combination of these divided. So this is the little formula right here. The possible roots are the factors divided by the lead coefficient factors, okay? So that would be 1 over 1, 2 over 1, 3 over 1, and 6 over 1, which is just all of these values. So once I start trying to figure out what are my factors of this equation, right, I would then start plugging in values. So the rational root, when you get the test in the quiz question, it's going to say, find all the possible rational roots. You would write this, but you would set it up like this. You'd set it up like this, and then finally you would write your answers like this. Now, if then the question says, oh, by the way, now I want you to factor, then you're going to start plugging in points that are from here. So like I would plug in, try 2. Let's try 2. 3, 2, 1, 0. You got to make sure that these are, descending. So I have a 1, I have a negative 4, I have a 1, and I have a 6. So we're going to go 1, this is 2, add down, we get negative 2, multiply across, negative 4, add down, negative 3, multiply across, I get negative 6, 0. Perfect. So that means that I have a 0. That means that 2 is a 0. So at 2 comma 0, I have my graph crosses the x-axis. That's a 0, okay? Now, a couple of things. I also know that 6 up here, that 6, is my y-intercept. And I also know it's a cubic, right? In a cubic, right arm up. We know that the graph is going to go up that way and down left. And we call that our end behavior. We call that our end behavior. And a lot of times people put EBA there. Okay, so the way I would write my answer, though, to set this up is this. This is going to be x minus 2 times, and then what's left. Just like we did in that practice problem. If you started with x cubed and you divided by, like a factor of 1, x to the 1 power, now the next term is going to be 1x squared. and then this is what's left. So minus 2x and then minus 3. And then you're trying to find the factors. So you do want to set this equal to 0. You're splitting this up. You've got x minus 2 equals 0, and then factor these two here. So we've got x here, a minus 3, and plus 1 is going to give me a negative 2. And so what you now have is you've got 2 as a factor, 2 is a 0. You have 3 as a 0, and you have negative 1 as a 0. And so these are the factors of this equation right here. Graphing this is 2. You've got one value at 3, and then you have one value at negative 1. So again, I just want to, just practice this. Is a little practicing because this is what we're going to be doing today too. And I'm not going to see you that day. This is my end behavior. Right arm up, left arm down. And this is a sketch for sure. You're just going through all of these values. And because it's a cubic, with each one of these, and we call this actually, it's called a multiplicity, but each of these is to the 1 power. That means it's going to go through. It's going to cross right through the x-axis. That's my graph. Those are my factors. And this is what we call the rational root theorem, like that. Okay. So try to find, we just did this. Check. All right. Sorry. All right. Find all the possible rational roots for the polynomial. So this is a different problem. I'm only asking you for the rational roots. I'm not asking you to solve. So remember to find this, you're going to take the factors of 6, and we actually have a name for this, and it's going to be P of x over Q of x. Okay, and these are the factors of 6 are going to be plus or minus 1, and this is comma, plus or minus 2, 3 goes in there, plus or minus 3, also 6, plus or minus 6. But then the factors of 2 are not only 1, but they're also 2. So now I have to come up with all the different combinations. Now it's going to be like 1 over 1, 1 over 2. 2 over 1, 2 over 2. 3 over 1, 3 over 2. 6 over 1, 6 over 2. And so some of these values will be repeating. All right, so realistically, if you write it all out like this, right, you get the plus or minus 1. You get 1 over 2, which is 1/2. Let me make that bigger. You get 1/2. You go plus or minus, you got 2 over 1, which is 2. 2 over 2, which is 1, which you already have, so you don't have to rewrite that. You've got 3 over 1, and then you've got 3 over 2. And then, by the way, just to make sure, remember that this plus or minus is over the whole quantity. It's not just over just 1. It's like everything, plus or minus. All right, and then 3 over 2, and then you have 6 over 2, which is 3, which you already have. Okay, so then realistically, you can start plugging values in, and in this case, we've plugged in a 2. Now you can, this is just another option for synthetic division. If I chose 2 to plug in 2 into my synthetic division, into this equation, you've got 3, 2, 1, 0. That works. So 2, negative 5, negative 1, and then 6. So I'm going to draw my line, add down, multiply across, add down, multiply across, add down, multiply across, add down. So I have a 0. So what this means is that in this value here, what I have is this. And I started with x plus 2, which means x minus 2 is a factor. And then this is what's left. 2x, it was a cubic. I divided by x, so now that has to be squared. Minus x, and then minus 3. Now, note to self, this is a factor. Yes, I found a factor. They didn't ask me that. They asked me to find all the rational roots. So right here, I'm actually done right here. That's my answer. But if you were asked to find all the possible roots, then you would start doing the synthetic division with the rational roots that you found that are all possible roots. They're definitely not all roots, right? Because you know that because this is a cubic, you can only have 3 roots. That's it. 3 places where my graph is going to cross the x-axis. That's all. And one of those places is 2. To find the other places, I mean, they could be right on the axis, or they could actually also be imaginary, meaning like off the axis too. So I mean, like there's lots of things, and they could also be not like perfect whole numbers. They could be, fractions and whatnot. I would probably use the quadratic formula to do this one. Although, I mean, I could check to see if this works. So I'm just going to try plus 3, and then let's try x minus 1. Let's see what happens. 3, this makes 3x, and then minus 2x. Okay, so I messed up on the signs. So let's see what happens if I change my signs. Negative here, and then plus here. So that would be a negative 3x, and a positive 2x gives me negative 1x, which is exactly what I wanted, which basically means that this is going to factor 0, and then there's my x minus 2, okay? So all of my factors would be negative 1. This is going to be 2x minus 3 equals 0, so 2x equals 3. X equals 3 over 2, and then this one's 2. So ultimately, my graph actually looks like this. Negative 1 root. Y-intercept is positive 6 going up here. Let's see. I got a negative 1. I got 1.5, 2, 3. So here's 1.5, and I also have 2. So again, this is a cubic, 2x cubed. It's positive. That means my end behavior goes up, right, down, left. So this means up, right, down, left. And try when you're making your graph to go through all the points. So, because they're all to the 1 power. So we're going down, up, and down like this. And again, by no means is this perfect, but it's just a sketch. But it's a sketch of what it actually looks like. Now, the factor theorem, right, takes all of the values from the rational root theorem, right? And it should be P over Q. So I'm going to take that and, oops, let's do it this way. I'm going to flip this. There we go. And what you're going to do is you're going to, for something to be a factor is this. You take all the values from your rational root theorem, and then you plug those values in. And you go, well, is this equal to 0? If it's not equal, then it's not a factor. Okay? If it doesn't equal 0, it's not a factor. So here's our equation right here. All right? So based on that equation, I'm going to plug in all the values. Let's see. For my rational root theorem, we're going to plug in all the values of 12 and this, remember, 1. So that's, it's just going to be plus or minus 1, plus or minus 2, 3, 4, 6, and 12. So hopefully one of these will work, but I'm not sure. So let's plug it in. So if I plug in 1, into the equation. So plug in 1, I get 1 cubed plus 1 squared minus 8 times 1, and then minus 12. So I have 1, 1, so that's 2. 2 minus 1 is 1. So I have 1 minus 8, which is negative 7. So negative 7 does not equal 0. So that means that x minus 1, that comes from this value right here, that means it's not a factor, and that's the factor theorem. Now, based on that, though, I don't want you to think that you just plugged in the value to no avail. Even though it's not a 0, it does mean that it is a factor. Even though it's not a 0 and it's not a factor, it is still a point. And so that's on my graph. So at 1, negative 7, that is a point on my graph. Even though it's not a 0, it's still a point. So that would assist me in graphing my my polynomial. Let's plug in negative 1. So we'd go negative 1 to the 3rd power, and I'm plugging this in again here, plus negative 1 squared minus 8 times negative 1, and then minus 12. This is going to give me negative 1 plus 1. Those are 0. That's gone. And then I've got 8 minus 12, which is negative 4, which means that F, I'm not saying F, I guess I'm using P. It means that P of negative 1, and this should be a P then, that means that P of negative 1 is equal to negative 4, which means it's not a factor. Okay, great. It's not a factor, but it is a point. So at negative 1, negative 4, my graph is crossing there. So you would just keep using these until you found a factor. So let's try 2. 2 to the 3rd power plus 2 to the 2nd power minus 8 times 2 minus 12. So that's going to be 2 times 2 times 2 is 8, plus 4 minus 16. So that's 12 minus 16, which is negative 4. And negative 4 minus 12 is negative 16. So for me, this right here, I don't have any factors so far. None of these were working. And so if I needed to find the factors, minus 8x minus 12, what I would then do is I would go to my calculator here. And for my calculator, I would go to y equals and clear that out. And I type in my equation. I would go, okay, x cubed, and I would go x plus x squared, so x squared, and then I'd go minus 8x t theta. Oops, that's not right. Okay, do it again. So we have x to the third power. I don't have a lot of patience for this. Plus, so let's go plus x squared. So we go x t theta and then square that. Okay, minus 8x, so 8x again, and then minus 12. So minus 12. And we get, that's it. Okay, now I would then go to my table and I would try to find where my zeros are. I see a 0 at negative 2 and I see a 0 at 3. Okay, and then I could just keep going and trying to find my zeros. If I wanted to graph that, that's what that looks like. Okay, it actually bounces off at negative 2, meaning, let me show you what that would actually look like. If, so we tried 2, but we didn't try negative 2. So I'm going to show you something. If I were to plug in p of negative 2, all right, and I know that this is a 0 because I already checked it. So I'm actually not going to plug it in. I'm going to use synthetic division. And so I would go plug this in here, negative 2, so 2 goes here. Negative 2 goes here. And then I'm going to get 1, 1, negative 8, and then negative 12. And so I'm going to add down 1, multiply across, add down, multiply across, add down, multiply across, add down. So this tells me that x plus 2 is a factor, but it tells me that my graph crosses at negative 2. Then what's left is this here, right? These three numbers. So those three numbers are, if it's a cubic, divided by x, this is going to be 1x squared minus x minus 6 equal to 0. And so therefore, when I split this up, watch, I get x plus 2, I get, what is this? X plus 2 again, and then this is x minus 3, and that's equal to 0. So that my zeros are going to be 1, 2, 3, negative 2 twice, which, by the way, if this value here is even, because that's like that, see how it's even? Remember I told you in the last slide that if it was to the 1 power, that it actually goes through just one time, it goes through. Well, if it's a squared term, then it bounces, and we call that a multiplicity of 2. I want to talk about that tomorrow. But so my graph, y-intercept is negative 12, way down here. So it is a cubic, it is positive, so my graph does have to have an end behavior that looks like that. So that's going up right, down left. But how is that happening? At 3, it's only to the 1 power. So that means it goes through that. Okay. Comes back up. But because at negative 2, I have 2 answers. It's bouncing. Bounces off. Bouncing off, it means it's tangent. And that's what my graph looks like. Okay. So the factor theorem, again, uses the values. The factor theorem uses the values from the rational root theorem. So here's my equation here. Use the rational root theorem to figure out what all the values would be. To find out the values, p of x over q of x, this is the rational root theorem. I only have plus or minus 1 and plus or minus 7 over, and then I've got the 2 here, plus or minus 1 and then plus or minus 2. So my options are either going to be with the rational root theorem 1 over 1, 1 over 2, 7 over 1, or 7 over 2. This is it. This is all I have. Those are my options. So plugging in those values, I could do that to find all the factors. Now, in this problem, they didn't ask me to find all of these these values for the rational root theorem. They just asked me to determine one thing. use the factor theorem to see if this is a factor. Well, in using the factor theorem, all I have to do is plug in f of 1. So I'm going to plug in 1, and I get 2 times 1 to the 4th plus 3 times 1 squared minus 5 times 1, add 7. So what is that? 1 to the 4th is 1. 1 times 2 is 2. 3 times 1 is 2 plus 3, which is 5. 5 minus 5 is 0. And then add 7 is 7. So P of 1 yields 7, which means that no, it's not a factor, it's a point. And there is a point on my graph at 1, 7. So therefore, if it's not a 0, then it's not a factor. That's the factor theorem. That's all it says. Okay? Again, using the factor theorem to find the values. Actually, I believe we just did this one. This is 8x minus 12. Let me just double check something. 8x minus 12. We did that. We've got all the factors. We're good. I'll get rid of that slide for class. Use the factor theorem to find all the possible factors. Actually, I would say use the rational root theorem to find all the possible factors, and then use the factor theorem to tell what the factors are. So this is a new question. You've got 20 is the value that I need to be considerate of. So the factors of 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, and plus or minus 10. That's it. So hopefully one of these values is going to divide in so we can start finding all the factors, because this is saying find all the possible factors. That's the rational root theorem. That's right here. This is all the possible factors. Second part of the question, and then factor. So that's what we're doing. Once we use the rational root theorem to find all the possible factors, then we have to find the factors. We have to plug the values in. So 3, 2, 1, 0. You have to make sure that that's descending. So you've got 1, 9, 24, and 20. So pick a number. This is the first time I've done this, so this is, I'm going to try 5. Let's try 5. So we've got 1, we get 5, add 5, I get 14. So now this isn't going to work. So you have to notice a couple of things. You got to, use your common sense. There's no negatives here, right? So therefore, this is just going to keep getting higher and higher, and I'm not going to get a 0. If my goal is to get a 0, I need to be able to have some negatives in here. So I'm going to try a negative 5 instead. So adding down 1, multiplying across, I get negative 5. Adding down, I get 4. Multiplying across, I get negative 20. Adding down, 24 minus 20 is 4. Multiplying across, I get negative 20. Adding down, I get 0. Success. Which means this is a 0. It means that x minus 5 is 0. So we're going to go x plus 5, like that, times what's left. So this is going to be 1x squared plus 4x plus 4. And setting these equal to 0, this is going to give me all the factors. So x plus 5, and then we have this, which is going to be x plus 2 times x plus 2, which is 2 plus 2 is 4, equals 0. And so what this means is that these right here are all my factors. Okay, these are my factors. If they ask me to write my answer in factored form, okay, then I would say this is equal to h of x. That's how I would write that. H of x equals this. This is what we call factored form. All right. If I were graphing this, however, then I would graph it like this. Negative 2, 3, 4, 5. This negative 5 here. This gives me this factor, negative 5. But then I have 2 negative 2's. All right. Meaning, see this x plus 2, there's 2 of those. And see this x plus 5, there's only 1 of those. So if there's 1 of those, that means I have a multiplicity of 1. 2 of them gives me a multiplicity of 2. All right. So that means at negative 2, my graph here is going to be what we call tangent. And then here, it's going to cross. All right. Okay. So anyway, my y-intercept is positive 20, way the heck up here. And I know because it is a cubic, right arm up, it's going to go up. So this has to go up. It looks like it's going to bounce off of that because it has to go down here. And it's going to go up. And then it's somehow going to bounce off of negative 2 and then just go up like that. Use the factor theorem to find all the factors. Okay, so 66 has a lot of factors. All right, I'm just going to try, let's see, we've got 3, 2, 1, 0. So 1, negative 10, negative 17, 66. So, 2. I'm going to try 2. Add down, multiply across, add down, multiply across, add down, 13, 1, 2, 3. That's negative. Multiply across, look at that. We are so lucky. So now that means that we have the parentheses x minus 2 times x squared minus 8x and then minus 33 equals 0. And so now you got to ask yourself, this is the kind of tricky. If I'm looking for factors, right? One of my factors is x minus 2. This is another factor, but is this actually factorable? We should use our discriminant shortcut. Let's just check. B squared, which is negative 8 squared, minus 4 times a times c, which is negative 33. So 8 squared, so let's just check. So that's what? 64, negative plus. So plus whatever 4 times 33 is. And I get 196. Oh, that's a perfect square. Square root of 196 is 14. So yeah, it's a perfect square, which means this is factorable. So now, right, and I know you guys are looking at that going, well, obviously it's 11 and 3, but I mean, we got to try different things here. So x minus 2, and then this is going to be x minus 11, and then x plus 3. Set equal to 0, we end up getting our factors. This is our factors. So if I wanted to write this in factored form, right, I would say, what's my a of x? So equals a of x, that's factored form. And if you wanted to graph, because this is day 2, this is something that you're going to need to know anyways. 2 is a 0, 11 is a 0, and negative 3 is a 0. And all of these are to the 1 power, which means they all go through. This is x to the 3rd power, which is an odd power. It goes like this, right arm up, which means my graph goes up like this and down like this on the left. My y-intercept is way up here at 66, which means that my graph is going to go down around way up here and come back through like that. All right, using the factor theorem, verify that x plus 4 is a factor. Now, I don't have to do too much other than just say, hey, I'm going to plug in this negative 4. So plugging in negative 4, I'm going to get 5 times negative 4 to the 4th plus 16 times negative 4 to the 3rd power minus 15 times negative 4 squared plus 8 times negative 4 and then add 16. So I don't know if, just to be honest, if I would actually multiply all this out on my calculator or if I would just type this into the my equation and see if actually, and look at my table to see if negative 4 is a factor. You decide, okay? 4 times 4 is 16. 16 times 16, that's 256. Plus 16 times 4 times 4 is 16 times 4 is 64. So that's going to be negative 64 minus 15 times 16. Minus 32 and then add 16. So take a minute and figure out if that is, I'm going to pause this for 1 second to calculate it. And working it out, yes, you end up getting f of negative 4 is equal to 0, which means at negative 4, we have an intercept, meaning it's a root, which means it's a factor. So if you, again, if this happens like this, right, then you're verifying that this is a factor, and that's all you're doing. The remainder theorem again, and this is just saying, hey, we don't have a remainder. If there's no remainder, we have 0. We did this in class. This is just saying something similar to the factor theorem, but the remainder theorem basically says this, that if you have a leftover value, that value is a remainder, but at the same time, it's also a point. So at CR, that's a point. Okay, so you can plug this in. We actually already did this in class, so I'm not going to work this out, but you get x to the 3rd, negative 4 to the 3rd power plus 8 times negative 4 squared plus 8 times negative 4, minus 32 does make 0, which means in this problem, which is different than the last problem, but it does mean therefore, that means therefore, yes, negative 4 is a 0. And if it is a 0, then it's a factor. And then if it's a factor, right, then yes, it's a 0. You could then say x plus 4 is a factor, and that's the factor theorem, right? Okay. All right, so this one says, I'm not going to use long division. So I guess I am. It says, let's review. So we're going to go to, long division. Whoops. Okay, long division, x minus 2. All right, and plugging these values in, you have x cubed, 3210. So x cubed minus 7x squared plus 13x plus 3. X times what is x cubed? So that's going to be x squared. That means I get x cubed, and then multiplying through, I get negative 2x squared. You should, while I'm doing this, pause the video, and you should do this and then see if you get the same answer that I do. Negative 7 minus negative 2 is plus, which is negative 5x squared. Add 13x, x times, let's see, negative 5, and that's going to give me, negative 5x, and that's going to give me negative 5x squared plus 10x. We're going to subtract this quantity. First term cancels. 13 minus 10 is 3. Bring down the last term. We have x times 3 is 3x. So this becomes 3x. 3 times that is negative 6. We subtract this quantity. First term cancels. 3 minus negative 6 is 9. That means that, number 1, negative 2 isn't a factor because I didn't get a 0. Which is totally fine. It also means x squared minus 5x plus 3 plus 9 over my divisor, which is x minus 2, is my solution. And if I was asked to write this in polynomial form, I would write it like this. I would say f of x is equal to, and then you put the divisor first, x minus 2, times this value, which is x squared minus 5x plus 3. That's my quotient. And then add 9, and then you're done. So this is saying find the remainder using the remainder theorem and using synthetic division. So the remainder theorem is just saying this. F of 2 is equal to 2 to the third power minus 2 to the times 2 minus 5. So this is saying 8 minus 4. 8 minus 4 is 4. And then 4 minus 5 is negative 1. So this is the remainder theorem. The remainder theorem is saying, hey, negative 1 is a remainder. That's what it says. Synthetic division does this for you. Put a 2 here. Oh, no, I did this wrong. What I didn't do was, see how this is 3? Actually, I haven't done this wrong yet. This is the remainder theorem. This right here in synthetic division, it has to go 3, 2, 1. I'm so glad I checked that. This is still my answer for this because that's just the remainder theorem. You don't have to have zeros there. However, or placeholders, this does. So x to the third power is 1. X squared is no value. I have no x squared, so that's a 0. X to the 1, I've got a negative 2, and then x to the 0, a negative 5. So add down 1, multiply across, add down, multiply across 2. Add down, multiply across, and then I get negative 1. The difference is this. This is still my remainder, okay, and that's the question. Find the remainder. The remainder is negative 1. But what's nice about this is that, well, this isn't a 0. So we really can't go any further. We just know that 2 comma negative 1 is a point. On our graph, we haven't graphed it. We don't need to. You can always use your calculator to do that, but you are going to have to do these without a calculator too. So that's why you're doing this now. Now, this one says, find all the rational roots. So for this, finding the rational roots, we're going to, finding the rational roots, I would try for 24 over 1. So it's just going to be plus or minus 1, plus or minus 2, plus or minus 3. Any number that goes into 24 is a possible rational root. So plus or minus 4, plus or minus 6, plus or minus 8, 9, 10, 11, 12. That's it. And 24, actually, don't forget that number. So to finding by factoring, to find the these are all my values that I could try. Oh boy. Okay, so in doing that, to find these values, okay, I always like to start with 2, but 3, 2, 1, 0. Okay, we're good. So 1, 4, -7, -34, and then -24. Okay, so this makes 1. We have 2, add down 6, multiply across, that's 12. I get 5, I get 10, 14. Is that right? No, that's not right. That, I don't think that's giving me a 0. 34 minus 10 is 24, but that's not going to give me a 0 because I still have to multiply by 2. So this is out. So 2 is out. So now I'm going to try a different number. All right, so every time you don't get one, you've got to try another number. I'm going to just try 3 before I start hitting some negatives. So 3, add down 7, 21, I get 14. 14 times 3 is going to be 2, 1, what is that? 42. Let's see here. All right, give me 1 second. I want to do something. Okay, so I got that. 14 times 3 is 42. 42 minus 34 is 8. 8 times 3 is 24. Adding those, I get 0. Perfect. So now what that means is this. We have x minus 3 times, if I started with x to the 4th and I divided by an x, now this first term is an x cubed. So x cubed, 1x cubed, plus 7x squared, plus 14x, plus 8, equals 0. I have to keep working because I'm still at an x cubed, and I'm not going to factor by grouping for this one. So now I'm going to take this term, this one right here, and factor it again. So I'm going to try factors of 8. This is done up on top. I'm going to try factors of 8. So I'm going to try, and notice 1, 7, 14, and 8. You guys see? These are all positive, which means that I need to have a negative value in here. So I'm going to try -4. And so we've got 1, -4, 3, -12, 2, -8. I am lucky today. Okay, so this means, this is what this means. Don't forget this one. It means that x minus 3 times this one, which is x plus 4, times my leftover here, which is x squared plus 3x plus 2 equals 0. So therefore, in factored form, I have x minus 3, I have x plus 4, and then I have x plus 2, and then x plus 1 equals 0. And this is a fourth term. This is a quartic. But so we haven't done one of these, but these are my factors. All right, these are all my factors. So if they ask me what my factors are, you write them in parenthesis form. But if they ask me what my zeros are, you don't write those in factored form. You write what the zeros are. Your zeros are 3, -4, -2, and -1. And just a little sketch and prelude to tomorrow. 1, 2, 3, we have a -4, 0. We have a -2, 0. And we have a -1, 0. We also have a y-intercept of way down here at -24. Now, the difference between this graph and a cubic is that a cubic, right arm up. But if it's an even positive power, so it's like x to the 4th power, your graph is like a parabola, like x squared. It's like that. So it's got to go up like that. Now, the difference is this. My end behavior, which you're going to learn tomorrow, is upright, because that's like this, like a parabola. But all of these are to the 1 power, right? 1, 1, 1, 1, which means that they all go through, and no bouncing off. So this is going to go through that, turn somewhere, through that, turn somewhere, turn through that. It's got to go through my y-intercept, and then it's going to go through that. So this is a sketch. By no means do I know how high up this went, and I don't know how low that went, but I do know, and I don't know how low this one went. But I do know this is like a sketch of what this this would look like. Last one, I think for this mostly, use rational zeros theorem to find all the zeros. So this would be, all my zeros is that 4 over 1. So my choices are plus or minus 1, 2, and 4. All over plus or minus 1. That's it. So I'm going to try 1s, 2s, and 4s. And those are what I get. And so I'm going to try, let's see, there is a negative in here. I'm going to try negative 2 because there's only one negative. So I have 1, 4, 3, 2, 1, 0. So I go 1, negative 3, 2, 2, negative 4. So we're going to do this, add 1, multiply across, what's that? Negative 5, multiply across 12, negative 24. That's too high. I've lost it. It's too high. Let's just try 1. See what happens if I plug in 1. Let's see. I'm going to go 1. 1 times 1 is 1, negative 2. Negative 2 gives me 0. 0 times 1 is 0. Add 2. 2 times 1, still not a 0. Okay, so now I'm going to try negative 1. So if I try negative 1, let's see what happens. I add down and multiply across. So 1, negative 1, that makes negative 4. That makes 4. 6, negative 6, which gives me negative 4, which gives me 4, which gives me 0. So I have a 0. So my x plus 1 already is a factor. So now I have to take these values right here. 1, negative 4, 6, negative 4. And now I need to come up with another factor that possibly might go through. And I'm going to try 1 and see what happens. So I have 1. 1 times 1 is 1. I get negative 3. Negative 3, I get 3. That's not going to work. So redoing this, I'm trying 4. Let's try 4. All right. And trying 4 is going to give me, let's see, 1. I get 4. I get 0. 0 times 4 is 4. This is 10. Okay, that didn't work. So now let's try negative 4. So you are just trying these values until you get that 0 to find all the zeros. And if these don't work, I'm trying some 2s again. 1, I get negative 4. That's a 0. Negative 4, 6 minus 4 is 2. Okay, so these didn't work. So now I got to try 2 and negative 2. All right, so trying 2, I get 1, 2, negative 2. Negative 4, 2, 4, and 0. Therefore, now I have another 0 at x minus 2. And then what's left is these three numbers. So I have x plus 1 times x minus 2 times x squared minus 2x and then plus 2. And then this right here on the right is going to factor, and that's going to be x plus 1. It's going to be x minus 2. And then this is going to be x. That's not going to factor nicely. So these are my factors. And so I would actually leave that like this. For this one, I would have to probably use the quadratic formula. So I'm going to leave it like this as finding the zeros. Oh no, it says might be imaginary. We're going to have to use the quadratic formula. So let's see here. X equals the opposite of b, which is 2, plus or minus b squared minus 4 times a times c all over 2 times 1. So that's 4 minus 8. 4 minus 8 is negative 4. Square root of negative 4 is 2i, which means that my my zeros are going to be, what do we have? 2 plus or minus 4 minus 8 is negative 4. Square root of negative 4 is plus or minus 2i all over 2, which means that my zeros are divide by 2 on both of these, and I get 1 plus or minus I. So that means that my factors are going to be x plus 1, or negative 1. My factors are 2. My factors are 1 plus I, and then my factors are 1 minus I. And so these right here, by asking me what are my factors, or excuse me, by asking me what are all my zeros, those are all my zeros. And these are my factors until I factor that. Finding the zeros again, you know that you can use synthetic division. This one wouldn't be awful because you know that you're pretty limited as far as you've got plus or minus 1 and you've got plus or minus 5 over plus or minus 1 and plus or minus 2. So you've got like 1, 1/2, 5/2, 5 to plug these in. So 2, I have no value for x squared. I have 3 and negative 5. So finding all those zeros, I'm going to try 1, negative 1. So we have 2, negative 2. We get negative 2, 2, 5, negative 5. Ooh, that's close, but it doesn't work. So I'm going to try 1 next and see if that works. And I add down 2, 2, 2, 2, 5. 5 gives me 0, which then means that my factors are going to be x, what did we try? 1, so minus 1, and then I'm left with 2x squared, which is right here. So I'm left with 2x squared plus 2x plus 5, and then factoring that, you can keep factoring x minus 1. I'm going to try 2x and x equals 0. So let's try 5 and 1. This one's not going to factor nicely. So in order to find all the zeros, I would actually have to use the quadratic formula to finish that, because I only have 1 0, and that's 1. So using the quadratic formula, you would go x equals the opposite of b plus or minus b squared, which is square root of 4 minus 4 times a times c, all over 2a. And again, these zeros are imaginary. It looks like 4 minus 8 times 5 is 40. So 4 minus 40 is negative 36. Square root of negative 36 is 6i. So I have negative 2 plus or minus 6i over 4. And so that's, I'm going to divide by 2, which gives me negative 1 plus or minus 3i, and that's still over 2. So all my factors, or all my zeros, are going to be 1, comma, and negative 1 plus 3i over 2, and negative 1 minus 3i over 2. And these are my zeros. Okay, so the last problem that we're doing here is this. And this is just a little bit different. And I am giving you this value at 3/2. So what I want to do is I want you to understand that if this was set equal to 0, right? If I were to plug this in as a 0, 3 over 2, right? Think about what does that mean? That would be like, to get it 2x, looks like minus 3 equals 0, right? So 2x equals 3, and then x equals 3 over 2. This is what we came from, right? So that means that this value is my divisor. So if this value was my divisor, think about what that would look like if you were doing long division. I'm not going to do that. Just look at the first term, 2x minus 3, right? 2x times what is 2x cubed? So that's just x squared. So think about that, 1x squared. Think about that when you're using synthetic division. So we have 2, negative 5, negative 1, and 6. So this is how it works, right? You add down, and then you divide by the value down here. So you add down, you divide. So that's going to be 2 divided by 2, which is 1. So now I'm going to go 3 times 1, which is 3. I'm going to add down. I get negative 2. Don't forget, you still have to divide by 2. So my next term is negative 1. Negative 1 times 3 is negative 3. Add down, I get negative 4. Still have to divide by 2, and I get negative 2 as my next term. Hold on one second. Let me move this. And then that goes there. This goes here. And then negative 2 times 3 is negative 6. Add down, we get 0. 0 divided by 2 is still 0. So what that means is that 3/2, yes, is a factor, which basically means 2x minus 3 does work. So 2x minus 3 times what's left, which is this x squared minus x, and then minus 2, which means I can still factor that to be 2x minus 3, and then x minus 2, and then x plus 1. So my factors are going to be 3/2, 2, and negative 1. And so, well, these are my factors. Yes, these are my zeros. And so these right here, if the question says find the zeros, this is my answer. If the question says find all the factors, this is my answer. So summary of what we've learned so far, we've talked about all of the end behavior, factoring, long division, remainder theorem, factor theorem, rational root theorem, synthetic division. And today we actually also did end behavior that looked like a positive from an x to the 4th power. And we even talked about multiplicity a little bit. Okay. we definitely covered all of our learning targets, and homework for you is this. And don't forget to do the exit ticket, which is on Canvas. Thanks so much for watching.